In this video, let us cover managing iceberg tables. More importantly, the iceberg tables created by Snowflake catalog. Let us see what are the offerings from Snowflake to manage the metadata of iceberg tables. It is very important to understand creating an iceberg table is one step, but managing the metadata of iceberg table is other step. That will help to retain the same performance. If not, there are chances that performance could degrade very badly. Let us go over what are the features available. You have metadata refresh, data compaction, manifest compaction, automatic clustering, snapshot expiration, orphan files deletion. Let's start from metadata refresh. The way to refresh metadata is using an alter iceberg table that would sync external table state. Setting an auto refresh equals to true on a table creation for continuous polling. The default interval that is set is 30 seconds, but it should be changed based on the use case. So metadata refresh is important to refresh the metadata if it is an externally created iceberg table. It is also important to set the auto refresh equals to true, and it is based on the refresh time interval part of the catalog integration. For heavy write operations, it is better to set a higher limit of refresh time interval, typically between 2 to 5 minutes. Let us see data compaction. Data compaction meaning combining small Parquet files into larger efficient files. It is enabled by default in Snowflake. Setting a target file size from 16 MB to 128 MB, or we can also set an auto. Typically, it is good to disable for rarely queried tables. Data compaction is important and to improve the read performance. Manifest compaction. Manifest compaction meaning reorganizes and merges small manifest files to reduce metadata overhead. It is enabled automatically and cannot be disabled. It would help to improve the query performance. Automatic clustering. If you set the cluster by on Snowflake managed tables, automatically reorders data for faster queries on the clustering key. It is not supported for external catalog tables. Snapshot expiry. There are several snapshots that gets created. You have an older snapshot and their unique data and metadata files are systematically deleted per retention policies. It keeps the storage cost and metadata overhead low. Finally, orphan files. When a deletion happens or snapshot expiry is triggered, it will also create an orphan Parquet files. DML rolls back may leave unreferenced Parquet files. Use table storage metrics to spot mismatches. By default, Snowflake doesn't delete orphan files. If it needs to be cleaned up, one has to call the Snowflake support for orphan file removal. So these are the list of offerings from Snowflake for metadata management. In a nutshell, it is very important to manage the metadata of Iceberg tables for improved query performance and reduce storage cost. In this section, let us cover metadata, snapshots, and time travel features. We'll also cover partitioning, retention, and undrop features. On the left side, I have listed snapshot model. On the right side, I've listed partitioning. We'll go over each point from snapshot model here. Each commit creates an immutable snapshot of the table state. A snapshot meaning an immutable snapshot for a particular commit. Data files are mapped via manifest files that again points to metadata files. Snapshots enable time travel. Query any snapshot committed within retention period. Third-party engines can time travel on Snowflake managed tables by Open Catalog or Catalog SDK. Snowflake deletes expired metadata asynchronously. Storage costs may persist a few days past retention. Undrop Iceberg table restores within the data retention policy. No failsafe for Iceberg tables. Configure protection at the cloud provider level because it is not managed storage by Snowflake. Let us cover partitioning. Snowflake supports hidden partitioning, lifestyle partitioning, also supports transform functions, and then read plus write support. What is hidden partitioning? Partitioning without exposing columns to the SQL. Transforms applied internally, that is, it's called year, month, day, hour, bucket, truncate. So when you create a table, you create transform function on a particular column saying partition by year of a particular column. So internally it partitions by that particular column. The partition column is not saved in Parquet files. Hive style partitioning. In the Hive environment, typically when you create a partition, it will create a column name and its value. Snowflake also supports Hive style partitioning because it could support multiple other engines for interoperability. Different engines may serialize values differently. Be aware of cross engine path interoperability. The reason being, if you create Hive style partitioning with one engine, if you want to read that from a different engine, if it doesn't support that particular partitioning methodology, that would fail. So it is very important to check whether Hive style partition to be enabled or not. Supported transforms. When you are creating a partition column, it would support an identity, bucket, truncate, year, month, day, hour functions. So these are the transforms that Snowflake supports. This would help to partition by a particular key at the table creation level, and it would also help to not have this particular column again added to Parquet files or rewriting the Parquet files. Creating a partition table as a Snowflake managed or externally managed by catalog linked database or REST catalog. We'll elaborate more on catalog linked databases in the next session. With this, we have covered metadata, snapshots, and time travel features.